Awesome. All right. So that is our little bit of quiet so that Ashley can find her spot in our recording. And we are going to spend this week, week 11, I think, talking about 3D modeling and 3D design, and then a little bit of 3D printing towards the end. This is a really exciting topic for all the makerspace things. It's the best planning that you can do for any engineers that you know. This is definitely a skill that they're going to have for most engineering jobs. And it really helps you take an idea of something that you want to make. And before you spend money on wood, before you've done a prototype or a test run, you can 3D model what you want to make. And sometimes that helps you make better decisions about how to make it, or it can even be what directly informs the making process. And so that's what we're going to look at this week and next week is how do you do the 3D design stuff? And there's no way that in 2 weeks we'll master it, but we can get our toes into that water. And then we'll look at how do you go and do the making. So, and a good example is this cello thing. I had some high school students that needed to make an instrument, and they designed this cello guitar that I think we talked about in the Ideas Week. So they 3D modeled all of that and then used the 3D model to inform all the cuts that were made on a CNC. And so it's a really great process to be able to model and then make. These are the topics that we're going to cover this week. We're going to look at a bunch of different 3D modeling software options. There's tons of these that exist out there. It's a great way to show off your power as a programmer to make a 3D modeling software. We'll look specifically at Fusion 360 because that's the one that I am personally going to recommend, but it's by no means the one that you have to use. Then we'll look at some of the big 3D modeling concepts, some of the more advanced out there concepts that are just cool enough that we should talk about them, and some of the weirdest ones too. And then the start of 3D printing. And so this week you're like, what am I going to do? It's probably going to be a little bit of 3D modeling and then like download something and 3D print it. So we'll talk about that as we get down towards the end. So the big thing about 3D modeling is that it's a software game. It's a computer piece entirely. And so here are lots of different options that all exist. Fusion 360 is the one that we're going to recommend. And this is a link to their website. And so Fusion 360 has a really nice setup. You can see that there's tons of this where there's a lot of cost to it, but the free trial is great. And that's what I'm going to strongly recommend you do. There's also a maker version of this. Don't pay for it. Do the free trial. And if you have access to an education account, like I'm a teacher, and so I get an education license. If you can get an education license as a teacher or a student of any kind, that is the best because it's full access and you can do all of the weird features and bells and whistles without having to pay for it. There's lots of other, however, lots of these different softwares hit a big price point. And so there's several around, like the expensive elephant in the room is Solidworks down here by Dassault Systems. This has been for a long time the industry standard in 3D modeling. If you're an engineer, that's what the company has for you. However, I heard that Melissa and Doug, the like toy company that's not too far away in Connecticut, they are switching. They're like in the next 6 months going to switch from Solidworks to Fusion 360. It's much better at cloud integration and like getting teams to work. And Fusion 360 has been a hard pitch from Autodesk to make that happen, to cut into the SolidWorks market. So those are two very aggressive pro level softwares. SolidWorks, you get a membership, or you get an account with your membership here. So if you wanted to go for SolidWorks, you can absolutely do that. Fusion 360, there's a free license for makers that I would wholeheartedly recommend. Tinkercad is for if you're feeling like you want to just dip your toes into the water. It's a fantastic option that you can do a ton of stuff with, but it definitely has a more approachable interface. For anybody who's just getting started, never ever done this before, it's a great place to go. Onshape is also really nice if you're a person who has just a Chromebook, and I know a lot of students who just have Chromebooks, so you can do Onshape completely and entirely in a browser. And then there's a ton of other weird options like Unity and Unreal Engine if you want to make games, Blender if you want to make open source movies. Openscad is a 3D modeling software that's done entirely by code. So you write code and 3D shapes pop out, which is fascinating and bizarre. Antimony is a strange one that is volumes first. It's real weird. And then there's a whole bunch of them, really. There's tons of options. But basically, if you were to try and take that weird collection of graphics for softwares and try and categorize them, I'd put them into 3 camps. There's the sketch and extrude, which is good for engineering design. That's what SolidWorks and Fusion 360 are, where you draw a sketch and then you extrude it into existence. That category is the main group where lots of these, where I think about CAD, that's what I'm thinking about. Then there's volumetric design, which is a little different. You have volumes and 3D shapes as the first thing that's a part of your work, as a first principle. And Tinkercad is one of those, where like you're dropping in a cylinder or you're dropping in a cube and it starts as a 3D shape. Antimony is another interesting one. Openscad falls into that category, which is fascinating. And then there's the 3D mesh designers. And those are things for like Pixar to use, right? Where you have squishy shapes that you can sort of mold and sculpt and do things. Interestingly, some softwares will sort of straddle the line, like Fusion 360 definitely can sketch, extrude, and mesh. So some of them are capable in multiple realms, but often you want to think about 3D design softwares in one of these 3 camps. Fusion 360 is what we're going to recommend, but these other 3 are also fantastic options. This is the one that I'm most fluent in personally, and it's got a free license for makers. And it also will let you do circuit board design and cam work. So if you want to have a design and then cut it, you can do all of that inside of Fusion 360. So it's a one-stop shop for lots of our things, instead of needing to get a bunch of different softwares to solve the same problems with the ones down below. And so with that, if we're going to lean into Fusion 360 with its free hobbyist licensing option, I will definitely send a hard link to that so that you can get exactly to that if you haven't yet found it, so that you're not searching. But Fusion 360 has a free hobbyist option that is licensed for a year. The qualifier for that is just that, like, I think as long as you're not making, I think it's maybe $10,000 a year from products that you've designed in Fusion 360, then you get to use it for free. So it's a very reasonable, most people who are a hobbyist will fall under that line. And so it's a great way to get access to this high quality tool. The interface then. So if you wanted to use Fusion 360, when you open a software like this, and this is generally true for lots of them, there's a whole bunch of different regions inside the interface. And so this is a photo that Inkscape or that Fusion 360 themselves gives. These like different regions, I don't think I knew the name of most of them, even though I'm fluent in the software until I looked it up for this. But like, here's where your files live that you play with. Here's where all the different pieces that you're designing live. Your data panel is where your files are. The application bar is up here. There's tabs. You can have multiple designs open at a time. This is where you set save and a few other things. There's a toolbar. This is the main way that you're going to design things, is across this toolbar. This has got lots of different features and bells and whistles in here. This is the one that's menus on menus on menus. It's all tied up in the toolbar. This is where all your stuff is inside of a design. The design in a canvas is pretty common. This little cube is good for rotating things. This is a right-click menu, and this is to view things. And then down here, across the bottom, that's your history. So there's lots of different ways that you can interact with this. And this is what Fusion 360 looks like. If we pop over to here, I'm going to just open up. Let's do Tinkercad. If we pop up into Tinkercad and let me see, cool. Sign in, I think it just does it with this. Yeah. So if I sign into my Tinkercad account, oh, I agree to the terms. You know, login things. In here here's a completely blank 3D design that I have. And so the interface is way different. If you pop into Tinkercad, like I want to make a cone, you drag the cone over. You can change, its interface is a lot different, where it's going to ask you to think about sort of shapes and things in different ways. So there's a ton of difference in how these can look and interact, which is for good or bad. There's also some similarities. This is made by the same company as Fusion 360. It's just meant to be in the browser and for beginning designers. So it's a great tool if you wanted to make, you know, like a fun stand, you could imagine something like this, and then move it up, get these things to be sort of set on top of each other. You could build all sorts of strange, like strange objects in all sorts of different ways. So there's tons of opportunity to use different design softwares and get them to do interesting and bizarre things. And they each have their own interfaces, which can be a little quirky. But if you're going for one of the professional level design tools, your design space is going to look something like this. This Fusion 360, I think, is nice because it will hide menus away when they're not useful. Whereas SolidWorks it feels like it keeps a lot more buttons on the screen all the time. Some people have strong feelings about how you should do that one way or the other, but it's good to make sense of your interface as you're going. Another thing that's pretty common, well, it's very necessary in Fusion 360, but common in lots of design softwares, is that you're going to have different contexts that you do things in, whether it's sketches or solids, drawings or renderings, and those might flip back and forth pretty quickly. In Fusion 360, I've watched people get stuck in the sketch context toolbar, and until you hit finish sketch, it won't let you out of this view, right? So there's some quirks to each one of these softwares, and I've got multiple videos showing you sort of an introduction, and I'm going to make another one this week, just so we can try and get a sense for how this stuff all works. Another interesting thing, if you're not new to 3D design in Fusion 360, but maybe new to Fusion 360, everything is an assembly in Fusion 360. There's components and parts and bodies, and SolidWorks, once you design parts separately and then bring them together, Fusion 360, it's already an assembly, and then you're designing the pieces of that assembly. It's a little esoteric. If you already 3D design, this will mean a lot. If you don't, probably means very little. But these are some things that I have made myself with students that have different pieces and parts, like the casters and bolts and hardware on here, or these are two sides and then a piece of wood that we cut so that we could bend it. There's tons of different ways that you can build with multiple pieces using this software. Another thing about some softwares, they have more assumptions in them than others. They're more opinionated. Developers will sometimes talk about opinionated frameworks, or in this case, it's an opinionated design software. Fusion 360 likes to help you, but sometimes that can be frustrating. Like I was drawing a circle and then a line, and it assumed that I wanted it tangent. And that might be true. Like depending on how you draw it, it might snap that in and it's perfect. And it might be not what you want. And so those are things that as you get deeper into this world, you'll get better at understanding, but it's often just a little subtle hint for how that works. If we pop into Tinkercad again, those details are a little bit more on the nose, and they sometimes do a nicer job of showing you where all those things fit in, so that if you wanted to make those changes, it perhaps is a little bit easier to see what's going on. So you can make fun designs with a little bit different interface, right? So pop over to here again. Those assumptions, though, you'll want to take a look at as you're building and designing to see how they fit in with your world. But let's say you hop into Fusion 360, and that's going to be your game plan. And it may not be. Tinkercad could be your jam. That's totally fine. But whether it's Fusion 360 or SolidWorks or any of the major main engineering ones, your main operations are going to fit into these four camps: sketch, extrude, revolve, and then some Boolean operations. So the first thing that you'll do in a lot is sketch. And so sketches like this, or this is a sketch from the doghouse video that I shared with everybody, where I just design a doghouse really quickly. And it goes from this drawing and a couple other drawings to make sense of what this doghouse should be. And so a sketch like this can inform what your 3D model is going to be and set it up for how you want to build things. And as I've gotten better at 3D design software, I try and imagine what an engineer might have sketched pre-computers, where they want to draw a doghouse like this, and then they draw the door, and it's all sort of one sketch together. And then you can use that sketch to bring extrusions into reality. But sketches are where you can easily set like dimensions for how wide you want the doghouse to be, or how tall you want it to be, or how big the door needs to be. All of those different details that are a part of your shape, you'll usually define them inside of sketches in a lot of different ways. And sketches work really nicely You get your own sketch menu in Fusion 360, and these are all of the different ways that you can draw, that you can modify, and constraints you can add. But learning how to do this is definitely a skill and kind of an art all at once. So it'll take some practice to get good at.
Where to set the scale?
Ooh, when you're typing in, that's a good question. And I do have Fusion 360 up. If I wanted to make a sketch, I would choose, like, I'm going to do a front view. And then I can set up a rectangle like this, where I just sort of go like that. And in drawing the rectangle, it's asking me what size do I want it to be. So I can either sort of drop it without anything defined, and then I can use a dimension tool, or I could define it in that instant when I was drawing it. So I could say that I want this to be exactly 5 inches wide and set those that way. But a sketch like this is how you'd want to start off most things. And so there's my sketch, sort of oddly floating in 3D now. It's just a weird surface. I'm going to pop this back to the home view. But once you have a sketch, usually the next thing that you do is you extrude. And so a sketch, like here's the doghouse, you can pull that into existence. And this is sort of like the circle on a toothpaste tube. When you squeeze the toothpaste out, you're extruding a cylinder, right? And so it's very much that sort of an action, except with this doghouse shaped drawing, I'm extruding a doghouse. Or you can extrude a negative where you cut away. And so then I'm extruding out the doghouse door, right? And so an extrusion is where you take a drawing and you pull it into the third dimension. And so it definitely takes some reevaluating how you're going to draw these things to make sense of it. But once you've got this, you can start to draw in 3 dimensions. And so here's my rectangle. You'll just use the extrude tool like this. And then you grab this surface and you can go in either direction. There's some other options, like here's a 1 inch out. You can extrude and do, if I grab that thing correctly, you can add tapers and things. Usually I don't, especially for beginning items. But in here, you can do extrusions that take that square, the 5 inch wide square, and turn it into a 3D shape. And so from there, I'm able to start to define what I want it to be. And so it becomes a game of just doing that a bunch of times over. So you take this and you sketch and extrude, and now I want to draw a circle here. And we'll do that circle, and then maybe this circle also, and then we do another one over here. We're just making like a weird blocky Swiss cheese. And then you can stay up there. And then you can extrude these shapes again. And so it's asking, how deep do I want to extrude? I can do an extrude cut where it cuts away from those things. So sketches become things that you can use to squish 3D geometry into or out of existence from each other. And so you'll have to start to think about your shapes in that way if you're going to use one of these sketch and extrude design softwares. But sketching and extruding is not the only way. You can also do revolutions. So there's lots of things that you might design that are very circular or symmetric in a radial way. And so here I've got this weird, like almost a loaf of bread kind of shape that I've extruded into a misshapen donut, I suppose. But in this case, you're, instead of doing an extrude that's along a straight line, you can do it along an arc or along a curve. And usually rotations like this can be really helpful. There's a lot of things that are rounded in one way or another. And so a revolve tool like this can be really helpful. It often lives right next to extrude in most of these menus, whether it's Fusion 360 or Solidworks. And so this is a really common tool that exists in most design softwares. The extrude and revolve are 2 really common pieces. Another feature that I look for if I'm thinking about that menu of all the different options is I often look for a combine tool that lets me do Boolean operations on different things. This is really helpful for a maker because you're going to want to design things that you can put together. And so that usually means that pieces will slot together. And so you'll have to plan for those connections to fit really nicely. And so if I'm designing this red piece with sort of some fingers or a box joint coming out of the top, then I'll have this blue piece that I'd like it to be next to. And so if I imagine putting them right over top of each other, I have this weird like overlappy situation where they're sort of blending the colors together. And that's no good. That actually means that there's a conflict where their volumes overlap. You can then use a combine tool to do a Boolean where you use the red one to cut away from the blue one. And then your blue one has the exact corresponding fingers. So just like you can do Boolean combine tools in Inkscape for 2D shapes, you can do the exact same thing for 3D shapes. And this is weird. I want to be very straightforward. It is not an intuitive skill, but once you get it, it can be really, really helpful so that you can design things that exist in 3D space and don't have conflicts when you go and try and fit them together. It's definitely something that you can respect a lot more. If you imagine boxes.py from last week, if we do the boxes pi festi, I think was the festi. If we go to here, you can imagine all of the different places where this would be useful inside of one of these trays, where you've got places where the little tabs fit, and you want to have fingers that go in and they fit together really nicely. So something like that Boolean operation would make fingers like that possible, where you can have a panel that's cut away and then they fit together really well. But that comes from these Boolean combine operations. In Fusion 360, since I have it up, we can do, let's come over here. I'll draw a sketch. And then, wow. Oh boy, that wasn't what I wanted to have happen. Here's a rectangle, drop that, finish our sketch, quickly extrude this and this. If I had two pieces that I wanted to fit together, I can do this. And instead of cut, I want a new body. Can do something like that, but now I've got a conflict. You can often, it looks like in a software where it doesn't quite show the right lines. But if I do a combine tool where I say that my target body is this thing right here, my tool body is this rectangle that I just added, I could join or cut or intersect. I want to do a cut and keep the original tool. If I do that, now I've got a crisp line there. And if I hide away my second body, I've made a cutaway that exactly fit it. So you can do those sorts of things where you have interesting operations that really lock your geometry together with just a couple of quick moves. And my original piece here was able to be kept totally in solid form. So that's the Boolean operations that can be really, really helpful. There's some crazy advanced ideas that once you start to get past those first ones, these become really helpful when you're starting to think about how you want to build stuff. As you're drawing sketches, more and more complicated sketches, a lot of the time you'll say, I would like this line to be perpendicular to the other one, or I want these two lines to be exactly parallel. You can use the constraints across the top here to make those definitions. A good one for beginners is you want to hold something in place. And so if you have a line or a shape that you want to keep exactly the same, you can use fix to hold it exactly where it is. Or you can say tangent equal, collinear is good. Your lines have to line up with each other. And these pictures, I think, are super helpful for actually making sense of what it is. The other thing that's worth knowing in Fusion 360, it uses these little sort of grayed out logos to show you that all of these lines are supposed to be vertical or horizontal. And then this tells you that these boxes are all in an array, that they're all from like a combo pair. So there's a few, these are the little hidden symbols in Fusion 360 that seem like details, but they're definitely important details. It's part of Fusion 360's 360 things to learn at once, which is actually fine. And the more you get into it, the more you like it. But it can be really helpful if you want to define certain things with your shapes. Another thing that's really good if you want to build something is to have a list of parameters. A lot of the time, if we're making something in the wood shop, you'd naturally think my piece of wood is 5/4 thick. So I want to imagine that, or my piece of acrylic that I'm using to build something is a 3 millimeter thick piece of acrylic. Inside of I would say a mature design software, it's going to have a place where you can input parameters like that. The doghouse I really like as an example, because you can input the dog height and the dog width and the material thickness. And you can imagine dog houses of a million different sizes for a million different types of dogs, right? My stepfather has a Great Dane. And so that dog house is going to look very different than a Yorkie, just the next door neighbor. And so you can imagine needing to put in these parameters that let you alter the core idea of a doghouse with just a couple of details being switched. And so if we have the right minute, it's good to take a look at how those fit. But it can be kind of amazing if you have a design that's all defined the right way. And if you just type in a new dog height, the whole thing magically pops in the right way. So there's some really cool design work that can be done. That's not always a goal in your designs, but sometimes it can be a way to make them look snazzy if you want to impress people with your designs. Yeah. Yeah. That's a really good point. Openscad is the best at this because it is a program. So especially on what we're going to look at as Thingiverse, Openscad is shines on Thingiverse because there's a lot of designs that you can download. Because instead of being like designed in a software like this that you may not have downloaded on your computer, Openscad, you change a couple lines of code and the geometry changes around. Because it's a program, works super nicely, and I've seen teachers where you can download a doorstop that you 3D print, and then you type your name into Openscad, and it's a doorstop with your name and your room number printed on it, so that the other pesky teachers don't steal your doorstop, right? Those sorts of things where you can have interesting changes because it's all code driven. It works really, really well for this. Rhino is also particularly good at this. And Revit is really good. There's a few different softwares that are very good at parametric design. Fusion 360 is easily very competent with it, but it's not like Revit is an architectural design software, and you can have it where if you're building a computer lab, if the wall is now 3 feet wider, it knows, oh, that's far enough that I can add another desk with a computer and a chair. Like you can build in crazy parametric things in some software. But this is very high level integration once you get there. But Openscad's fantastic if you're good with the programming. Joints are also really nice. And so in here, I'm slowly dragging the knife in and out. This is an Autodesk tutorial where your geometry for like a box cutter could be well defined. And then a joint would let you slide along that piece and model how it's going to work in real life, even though you've never built it. And so joints and connections like that can be super, super helpful to really understand a model and how it's going to work before you put it into existence. This can be very helpful if you're trying to build a complicated thing. Definitely this gets used if you're designing a car engine, which I would expect none of us to do. But you can imagine needing the cylinders to be able to move, getting the linkages to go, having all those things defined and connected is going to be a really important part of any design software so that you can test to see that it's going to work before you invest money into trying to build a prototype. And so the better at this you are, the more digital prototypes you can build rather than having to try it and then see if it works, and if it doesn't, go back to the drawing board. You know, it can make it smoother, but it's not a first thing to try and learn in Fusion 360. Another thing that's really cool is that you can have patterns. And so there's a pattern tool for Create that's really fascinating, where you can have weird serpentine shapes, and you can imagine like getting a bunch of screw mounts throughout that. You can have them follow patterns. So if you really want to get ornate pattern work, which can be great for artsy sorts of things, or for very elaborate constructions, you can get patterns to do all sorts of fun stuff. But this is, again, an advanced thing that not everybody's going to get to. I'd be surprised if many people wanted to use this, but it's really powerful. So then there's some alternate methods. These are so weird that I don't want anyone to try and go for them, but it's worth mentioning them because they're so cool. The first one is generative design. This is very new. It's actually a paid feature inside of Fusion 360, unless every so often they have like a sale where you can try it for free. This is where you take a design where you want to have some brace that connects things, and you input the constraints to the computer, and then it designs the most optimum material use possible for what you describe. And so it's got this crazy algorithm where you put in the initial design constraints, and then it tries to come up with 1,000 solutions. You choose the best ones, and then it goes through that design cycle again and again and again. This is how we're going to get to, this is where, you know, you build alien spaceships and they look like this. Perfectly optimized material use. It's independent of the stuff. There's all sorts of generative design things where you can have a computer do the design work for you, and then you're just evaluating it. It can be a great way to make aerospace parts because you're getting the least weight for the most efficiency. And so it's a really cool process. Topology optimization is another feature that's like, it's close, but is not is actually free. So there's a few different options here for things that you can do. Formlabs says a lot about it. You can read a lot more if you want to. Here's a really cool high-end piece of design work. Nervous System Labs is fascinating. It's a parametric design company where you can download and then 3D print a dress. And like there's a dress designer where you can choose how much spacing you want, where you want the things to be. And this dress is 3D printed on a normal size 3D printer. The file comes to you all wrapped up on itself so that it prints in one block. It's a print in place part. And then you pull it off the printer and give it a hard shake, snap all the joints, and the whole thing just falls apart. It falls into dress form. It's an insane file type. It's a high-end like couture garment. It's not like a normal thing that you normally wear. However, it's fascinating that it exists and is possible. The same is true for their bracelets and jewelry. These are also parametrically designed where you can input different organic shapes. You can sort of nudge what these look like, and they get turned into shapes and files that you could have 3D printed from a service like Shapeways, which is able to print in genuinely metal materials. If you wanted to really print something in, I think Shapeways will print things in gold, but like you better really want it because it's going to be very expensive. And so in here, there's these different ideas that you can get where you're paying for the service. If you wanted to, this is what some of those design files might look like in Rhino, where you can have inputs and outputs. This is a whole different design system, but it gets at the same idea. And then the Metro Parasol in Seville is a really cool example. That's all plywood, right? It's all wood. Yeah, it's all wood cut and made into that wonderful arbor shape. And that would have all needed to have been programmed together. So you get those organic flowing shapes designed with perfect cut lists so that you can make it for what you want it to be. And so these are all fantastic examples of really high-end parametric design. And if you haven't ever been to Nervous System Labs website, you totally should. Like here's their crazy, these are all of the design solutions that they have. So it's just awesome to scroll through here and get inspired by what they've made. So there's that. Another thing that's very high end, this is not what we're going to be doing on a regular basis, but maybe from time to time Sinem does for work, is some of these 3D renderings and simulations. So for these are all different like strain and stress. You can imagine this is like an I pulled this from Airflow when we were very early pandemic, and there were lots of these coming through the New York Times. Here, there's different stress and strain models for how I think this is, if you're injection molding this plastic part, when and how aggressively the injection molded plastic will come into the form. Here's flow over or air resistance from a race car, flow in through some sort of a car part. You can imagine needing to simulate different things. And so you get these strange rainbow colors that can graph out strain or flow rates or different properties, so that you can make real in-depth assessments. This is all built into SolidWorks and Fusion 360. It's just hard to make work the way you want it to. This is the sort of thing that if you can do this well, you should be being paid as an engineer to do it, for sure. But let's say you have designed something. All these back to like Tinkercad and somewhat reasonable shapes. Let's say you've got your Tinkercad design, this thing, whatever this is, a little Tesla coil that you've made. If you wanted to make this real, you could absolutely do it with a 3D printer. And so if we have this thing, we really love it, we could export this as an STL and then print it on the printers downstairs. And we'll go through some of the details with that, but you can take this shape and download it so that you can just press print and it'll come into reality. But as we're doing that, we want to pop in and take a look at how this works. So we're going to start this discussion. 3D printing is sort of a long, slow process, but it's really cool. And so now we're going to 3D print most of our 3D designs. There's some people that absolutely love 3D printing in a way that is hard for me to understand. It's really, really cool. But I think that it's not always the best solution to every single problem. And so you want to take that carefully. We do have many different types of printers. So I think that if you're choosing the right printer for the right job, you can do a lot better. This is Benchy, a traditional testing file so that you can see how well your 3D printers are working. And this is, if you haven't done anything yet, this is a great way to get started, to just pick something and 3D print it for the sake of seeing how that looks. So 3D printing in general is pretty nice and straightforward. We'll be able to take a look. I think I can even maybe even pull up Octopi here. But this is really neat. Then another nice thing is that most of our processes downstairs are the sort of thing that you have to start and then you stand there. Like poor Ruby is downstairs next to the CNC and she's been there for 4 hours. It's a long time to be running that machine. But 3D printers are different in that they're set and forget. So you can start them and then walk away, which is really nice. I wouldn't walk away until you're a layer or two in, because the first layer is the most important layer on a regular Prusa 3D printer. But once they get going, it's pretty safe to walk away. And then the next day you'll come back, or a couple hours later, you'll come back and the thing will be 3D printed. A good example are these fidget spinners that are sitting here. And for people who are watching at home, they're 3D printed fidget spinners around real ball bearings. And so these I just set up while I was doing something this weekend, set them onto the printer, and it said 3 hours and 9 minutes. 3 hours and 9 minutes later, I had 3 fidget spinners. And so they just pop off of the print bed, you pop in your bearings, and they just work. So 3D design and 3D CAD is really cool to use with 3D printing. You've got lots of options to make cool stuff. But 3D printing is sort of its own process. And so I would imagine that there's 4 different steps in that. The first is to have a 3D model that you've come up with in a 3D design software. And if you've got something that you really like, most of the time you can right-click a body to save an STL. And so here we are in Fusion 360. Let's say I really like this shape, this one specifically. I can right-click on that and save it as a mesh, which is an STL. So the words for this sort of change a little bit. But I want my format to be an STL in inch type. I can even preview the mesh to see sort of what it's going to do. And if we look at this, there's my geometry stored in a strange output. You can see it's all triangles, and we'll talk about that. But basically, this is like the PDF of 3D shapes. There's a couple of different options, like STL, you'll notice wasn't the default. There's 3MF and then OBJ. There's a couple of options for these. But this is the standard exchange format between different file types. So for that, you want to have a 3D model in some design software, and then you export to an STL. The STL is important because it gets rid of all the weirdness that's Fusion 360, and it makes it into something that you can just print. Instead of being a Fusion 360 file, it becomes an exchange file that you can go back and forth with. Then the STL file, you'll need to import into some sort of a slicer. And so the STL file goes into a slicer software, and I've got one pulled up here. Here's Prusa Slicer. So there's my 3 fidget spinners, the things that are in the room. And these were designed like this. And so here's the 3D model, the 3D shape brought in. Those are STLs. And if you look at them really close, you can see that their shape isn't super well defined. There's those rectangles and things on there. They're not perfectly smooth. But the slicer takes this geometry, which has not got any detail, and it turns it into this, which is all of the different cuts and movements and things that it takes to make the 3D print. And so you can see all of these different layers. There's the first layer of the print, and then it sort of goes up through the 3-dimensional shape, laying down layer by layer from the 3D printer. And so a slicer takes your 3D geometry like this and turns it into those layers so that the machine knows exactly what to do to make it. This is its own software. Presumably this is built in or part of, almost built into Fusion 360 so that they can integrate well. I haven't, if they have one, I haven't used it. But a slicer like Prusa Slicer is going to be perfect for our Prusa 3D printers downstairs. And so it's a free download also, so it's no problem to get this and to use it. It's nice and easy, and its default configuration is exactly what you want to use on our printers. So you basically just install your import your STL like this, import STL. You can see it's got lots of options, STL, OBJ, 3MF. You import that and then click print, and it's that easy. So you have your STL, you bring it into a slicer. So Prusa Slicer, SLI C3R. or Cura. And then you'll take that and put it into something so that you can drive your 3D printer. We're going to look at Octopi in a second. You'll need to make G code. So what a slicer is doing is it's going from STL to G code, which is what actually drives the machine. And then you'll get a finished 3D print. So model to STL to G code is really the path we're going to go. Octoprint is how you get there. And so Octoprint is something that we here at MakeHaven use. It's how we control our 3D printers, which is really actually a super interesting project in and of itself. This came from a maker who wanted to run their 3D printer in a more web-friendly way. And the way that we interact with that here, let's see if I can get to it. Octopi 2, MakeHaven. Ooh. Octopi is a web interface where I can see what's going on with the printer downstairs. So we'll ignore this. This is, I'm able to look at what's being printed, visualize. And so I'm able to see what's being printed on the printer that's downstairs. I happen to be on the MakeHaven Wi-Fi, so I can do this. This does not work if you're at home, but since we're on the MakeHaven Wi-Fi, we can totally do it. And so I can look at the temperature of the machine. You can see that this is the actual temperature of the machine. It's 93% done. It's got 40 minutes left in its print time. You can use this to manage all the different things. And like, here's the files. There's my fidget spinner. So if I wanted to print this, once the one print is done in 40 minutes, I'm just going to click on this and then click print. And that's it. That's the whole show. I need to have uploaded it as a .g code file, which is what Prusa Slicer spits out. But once you do that, you upload it into here, click print, and it just happens. So that's Octoprint, which is a thing that we'll get to. As you get your 3D printer badge, which is the thing you're probably going to want to do over the next 2 weeks, you'll go through this process and see how all this works in detail, which is really helpful. There's a couple of 3D printing gotchas. The big one is time. A 3D print takes a long time. Do not expect them to be fast. And the bigger it gets, the longer it takes. I've definitely printed things that take more than 24 hours. It's not hard to find something that takes more than 24 hours to print if you want to print something that's reasonably large. That's why most 3D printed things for a lot of beginners are sort of trinket sized. Little knickknacks or these fidget spinners are a good example. They're very flat. The taller your 3D print gets, the longer it takes for sure. And so by being flat, these were only 3 hours for 3 of them, which feels like a very fast 3D print at this point. They can get very long. Other gotchas for 3D prints is that because the way this works is you're sort of squeezing out plastic onto a bed, you can't really print into nothing, right? There's overhangs that you might have. The Y prints out generally okay because each step up on the Y is kind of half supported by the Y. The H does okay because it's bridging a gap, but the T comes out really badly because the bottom of the T, if you imagine the very first layer, it's going to go out and back over absolutely nothing. And so it'll ooze out plastic, but it doesn't have anything to sit on. And so it comes out really poorly. If you do it upside down, it comes out great. And so there's totally lots of things to choosing your design so that they're going to be printable, where you may not design it to be printed the right side up, the way that you intend to use it. So there's some cool things that you can do to your designs there. Another thing that's a really good solution is like, here's a Bulbasaur. Bulbasaur is not going to print well on any surface. And so you can print Bulbasaur with supports underneath. And these happen to be different color supports, but that's plastic that you put into the design or the slicer puts into the design that you intend to cut away. Inside of Prusa Slicer, it's as easy as just supports none or supports on the build plate or a couple other options, right? But you can just check the box and it does it. And so it'll choose to slice it in and give you what you need. For example, and so here, let me turn this to none. For this particular design, I've got these things that sit on either side of the fidget spinner. If I were to take these down and sort of go down into the bottom, see how those are much skinnier on the inside? These would come out terribly because they go from being skinny to being a big disc. And that big disc would be printed over absolutely nothing. There's nothing underneath it. And so for that reason, I basically need the supports so that when it slices it, it adds in a bunch of this material that it colors green just so I can tell what it is. So that when this first layer happens, it's on something, right? that here's my nothing, and then it does a pre-print layer and then the print layer on a surface. So that's what the supports are for, which is really helpful. Yeah.
Turn out better if you place them on the opposite space. You can flip them.
I wondered about that.
That might like tip over still, but maybe it won't.
No, you're totally right. And I was looking at the angle of this. So there's basically an angle for how much you can overhang. And I was trying to decide if those were 45 degrees or not. My judgment was that they were a little too overhung for it to be okay. But I think if I flipped them over, it might be fine. Maybe I should do that. This was good for a demo though. So, you know, but what's up? Oh, just thinking about these different details are all sorts of things that you get better at the more you print. It is not, there is nothing intuitive about what we've just gone through with those supports. So don't feel like you're going to jump in and automatically know. You're going to have 3 or 4 prints go wrong, wonder why, have a conversation with Carrington or like some of the facilitators down there, and then talk about why it worked, why it didn't work, and then eventually you'll get the sense of how to make it happen.
It's conical shaped things anyway.
These are to like, I don't have them on any of my fidget spinners, but they like help you hold it in the middle of the bearing so that when it spins, you're not grabbing the metal. Oh, it depends a lot. Sometimes it's super easy and sometimes it's really hard. For these 6 things that I actually did have supports and broke them apart on, I think 3 of them, and it's pretty random, 3 of them at random were just like kind of half fell off. And then there was one that I needed to like stab with a putty knife to get it to separate. In a perfect world, it would be like just a light little snap and it pops off, but it's almost never that nice. And then it's different for different printing processes. So you just got to sort of get it. A lot of 3D designers, 3D printers will make their designs so that they are 3D printable without supports. And I think that's probably true about this design. If I flip those over, the angle is probably just the right one so that I could print them upside down without a problem. But you know, it was easy enough to print them with supports in this way.
He said he put on the wish list.
Yeah.
I don't know if he did, I couldn't find it, but the cruisers downstairs support multiple extruders.
Oh yeah.
To use a different filament for the supports, ones that can be washed away.
Right. And so that's what this is. It tends to be like a milky white color, that wash away stuff. And in hot water, it sort of melts off. It does work really nicely. It just gets real slimy and you need a dual extruder, and we only have one. It is really cool. I've seen used a handful of times when you have a very intricate part and you could break it by trying to pull off supports. It can be really helpful then. But if I get, most of the time I'm printing brackets and not like decorative things just by the nature of what I make. And so usually I'll instead try and design so I don't need supports. But lots of people who do artsy things, they always are going to have supports and they need to do that dissolvable support material, which is really cool. Other things that you might need to do that you might have noticed in the slicer, there's a skirt or a brim or a raft. If you have something like, here's a bust that's going to have a small footprint on the bed, but a big wobbly thing on top, it can often be helpful to think about how you want to get its first layer on the bed. Because that's the most important layer to keep the thing from knocking over, especially for tall, skinny things. And so if your bed sticks really well to anything that's on it, a skirt like this can be helpful. That little ring is just so you can tell you're not going to bump into stuff. Then a brim is a little extra added connection so that if the edges of your prints tend to curl up, it'll curl up in a useless part that you're going to snap off anyways. And then a raft is for if you really have something where you want to have, where you don't like the bed surface. There's a few reasons why you might use a raft, but this is for if you really want to try and isolate from the bed at all costs. They can add a lot of time though. Yeah. So what should you do for the week? What are the things that actually like take away from this? because we just talked about a lot, and 3D design and 3D printing is a very deep well of things to get into. First off, I want to say we basically have 3 weeks on this. We have this week and next week, we're going to do lessons like this. And then the week after is the week that encompasses New Year's Day or New Year's Eve, New Year's Day, and Christmas. So we're just going to take a wildcard week. So you've got extra time to practice, to come in to print, to do whatever you want to do. And so we'll have 3 sort of weeks dedicated to 3D design and 3D printing. So more opportunity to 3D print your gifts for people if you want to do some of that, or to, you know, a ball that you can drop that has embossed on it 2022. Hope it's better, right? Those sorts of things that can be really nice. And so this week, I would say download and install Fusion 360, or make an Onshape account or Tinkercad account. Try some of those. If you absolutely know you want to go after one, try it. If you want to just try out the other ones, all 3 of these have free levels, so they're easy to try and make work. You could do the official tutorial series from Autodesk if you want, especially the interface, the user interface, and then the components and how those fit together. You could design the representative doghouse. This is a video that I've linked. You can just sort of watch and follow along. It's 20 minutes of me just talking about Fusion 360. Try something else out if you want to do it. You could create your own first 3D design, or try 3D printing a small design that you've made. And so just something small, you don't want to go too crazy, but just find something that you want to print is a really cool resource. Here's the doghouse. This is sort of the representative doghouse design that I was talking about, where you may just want to design this so that you can draw the doghouse shape. I use some parameters like dog height, dog length, dog width, and then material thickness to define this and describe how it goes. Fusion 360 also can output drawings like this if you want to. But you could design this just to sort of get your chops in doing that design work, is a fun way to go. But some people will never really want to do this sort of design stuff, and that's completely fine. If instead you're just going to nerd out on 3D printing for the next little bit, I think that you'll want to eventually 3D design. But a good resource for that, if you just want to check out 3D prints, is to go to, there's a whole bunch of these services, but the most famous is Thingiverse. If I spell it right, Thingiverse like this. This is the most famous. This is a MakerBot project. And Thingiverse has tons of different designs that you can just download and print. More recently, they've added in like where you can tip the designer and some of those features. But you can download these and print them so that you can have adapters for this. Or here's like a lithophane, which is a really cool 3D print where the thickness of the print determines how much light gets through. And so you can see cool images come through like that. Yeah, there's a whole, Prusa probably has their own. Do you know what it's called? Prusa. Oh yeah. Yeah, and there's lithophane generator. There's some really cool image to lithophane generator. So if you really like that idea, here's some other cool things. Bruce is doing it the much classier way than a generator, I think. But you can do this where you have pictures that are mapped into grayscale color. So if you wanted to do this, you can have this, and then this pops off the 3D printer. These have the benefit of being exceptionally flat most of the time, like these heart ones. And so you can 3D print that way. You get some crazy detail for like this bird design, or there's all sorts of different things that you can do. Color lithophane seems a little tricky, but these are tools that will let you use it. So I think you can, some of them are free services, some of them are trickier, different, some of them try to be paid services. I sure will. I'll put it in after this. But we go back to Thingiverse. In here, there's all sorts of crazy stuff. Like an always favorite is cat armor. And so you can download and print armor for your cat, or this is stronger cat armor, or, you know, like little things that you might want to imagine. This is the classic cat armor design, slightly modified, where it's a few of these that go on to, it looks like that's on a tiny dog.
That's a weird looking cat.
That's a very strange cat. But these armor pieces that you can just download these and then print. These are going to come to you as STL files. So the thing files are going to be STLs or maybe OBJs, where you take these and put them into your own slicer so you can set the settings for your printer. But this is the sort of thing that Thingiverse really does well. If I were to recommend one category, I would say print in place is really cool. These are things that if you search for them, when you print them, they come together with hinges pre-made. So like this little vise is going to come all printed at one time, and the threads and body are all just going to sort of snap and then be able to move relative to each other, where you can print a nut on a bolt and print them all in one go. It's really cool. So there's some really cool design stuff that you can do that let's do print in place heart gears. These are this has got to be, some of these heart gears are really, really cool, where let's see if we can find if there's a video of these, but these print with little, and these may not actually be print in place, but these heart gears where the whole thing will be able to spin and move, screwless heart gears. There's a few different options where these gears will all turn relative to each other. And so you get very complicated geometries. Some of these things are only possible because they're 3D printed. Let's do print in place octopus. I spelled any of that right. Yeah, these things, these come off of these print with their legs totally flat on the printer. So it's got this cute little octopus. It will print exactly like this, but all those tentacles are just interlocked to each other. So once you pull it off of the printer, those legs become really floppy and really fun to play with. And so they've got enough looseness and tolerance that you can get them to sit on top of each other, that you can have them print. Here's what they print out like. You can see that halfway through the print. And all of these different connections are being made as it's being printed. It's really incredible, the sort of stuff that people have come up with for designs. And I would definitely recommend that if you just want to download and print something, you could do a lot worse than this particular design. It wouldn't tell you, but if I download this file, and so Tip the Designer is definitely something I would encourage if you really love the design, but there's not really any pressure to. But in here, you download this design. Oh, it popped up on the other screen. And then you just extract those, and I'm doing it off screen. It's coming. Here we go. And so then here's the design file. And if I go into Prusa Slicer, file, new project, yeah, that's fine. I can just import that STL. And so that comes, it's in my download somewhere. This right here, files, and cute octopus, no supports. And so there's the design, right? There it is. Here, and so software takes that 3D that someone went to a lot of effort to make, and I'm really proud of them for doing it. Whoever is, we'll make sure you get a shout out in the description. But this design, then you'd print out, oh, and that's got supports turned on by me. That's silly. And so here's the design. We should have all of these layers that it says to print it. And you can see as you go through there, it starts off and it makes those hooks interconnected as it prints.
Say if I want like in the my nephew.
Sure. Yeah. Yeah. Sounds great. It's down here, 3 hours to print this octopus. So you set it up and you let it print, or you find a friend, you say, we're going to print 3 of them. And maybe it takes 8 hours, and then 8 hours later, you have 3 of them. In order to do that, there is some software. It would be hard to do that from an STL. But there is some software that exists out there. Its name is Meshmixer. And it was free last time I thought about it, but Meshmixer, it contains many of the features. I think you can still download it, and so you might want to download it while you can. That lets you sort of modify STLs, which normally is like secret magic that you can't really do.
You have to import as a solid. Then
Oh yeah. FreeCAD and SolidWorks import as a solid is what you're saying. Yeah. Blender, you can play around. Different ones have different levels. This is the Autodesk solution, but different, different places have found different ways to do it. Because I am not one who typically designs in meshes, I struggle really hard with this myself. But some people are always designing in meshes and they can make really cool stuff out of this. Here's a metal piece that was, printed in metal. But Meshmixer is got a lot of cool organicness to it. And then there's all the other options that exist out there too. We do not. A 3D metal printer. Well, we have a 3D carbon fiber printer, which is not a metal printer. The structured layer sintering, SLS printer. And so we don't have one of these either, but if I can find a video of SLS metal printer, these are really cool if you ever get a chance to see one. Directed metal layer sintering. I don't know what this video is. Hopefully it's useful, but it's mostly an ad. So I'll send you a good link later. But basically it lays down a fine layer of metal powder, and then it uses a layer to melt it until it welds it to the layer below. It's really cool. That is an exceptionally expensive machine. Like each machine is, I'm going to go, and this is kind of guessing, $2 million. Like they are exceptionally expensive machines, but they have no supports because each layer is a complete fill of the bed, and you get to reuse any material that you didn't use in the print. So there's some really fascinating things about them, but they're just well out of our price range as a group. But if you wanted to order things, you can absolutely order things from Shapeways and a few other services if you want to outsource your 3D printing. This is very expensive, I want to say. It's amazing what they can make. They have those expensive machines, and if you want something that's made at that insane level of detail, they'll be able to do it for you. In 10 3D printing technologies, 90 materials and finishings. This is a Dutch company, but they have a site in, I think, Brooklyn. So they have a local facility where they do this. And so you can get things printed in all sorts of crazy materials like stainless steel or nylon or all sorts of stuff. So there's tons of different options and different companies use them. There's all sorts of different ways. You can actually ask to tour their facility if you're ever in the city, which is really cool. And I would recommend you do it if you get a chance, but they cover all sorts of strange stuff. So there's tons of cool opportunities there. But we sort of got on a side tangent and I want to bring it back together. The things that you should try this week is try some 3D design software, find some little thing that you want to 3D print, and then throw it onto the 3D printer. You can get your 3D printing badge pretty quickly. The machines themselves are actually pretty nice to use, and you can use Octoprint from your laptop on MakeHaven's Wi-Fi. All you need to do is go to Octopi, and I think I have it open on here, one of these. Yeah, Octopi with the number.makehaven, and then everything else will pop up. Oh, yeah. Right. And so you'd want to do http:// like this //. Yep. And so you do this, but we can go to Octopi 3, which is just another one of this is actually not a 3D printer in the space, but it does have an Octoprint instance. So these are all tied. This is actually if you're interested, these are being run by Raspberry Pis connected to the 3D printers. And so it's a cool Raspberry Pi project that's tied in there. So that is the plan for the week. Get yourself into the space, do some design work if you want, 3D print some things, and we're going to go into more processes beyond 3D printing for how you'd make out of a 3D design file next week. So we'll look at how do you take these and turn them into laser cut designs? How do you turn them into other sorts of designs? From a 3D design software, because that's a really fun way to make all sorts of cool stuff also. Awesome. So that is the main talk, and then we wandered around a little bit, which is always fun to do. And now it's a great time to do show and tell. So let's hop into Zoom controls. And Renee, you have your you know, you're right there and your camera's on. Would you be willing to share first?
Sure. So
Excellent.
I made a few things this week. I did this little portrait of my cat. So I don't know if you guys can see, but yeah, that was pretty cute. I did this little Hylian shield from Zelda. So I made that for my brother. And then I also made this little like keychain with my grandfather's signature for my dad. So I had a lot of fun with the laser cutter. I think there's like a lot of cool opportunities there, and I'm pretty excited to use it more, but I definitely like got comfortable with it. And yeah, I'm just like excited to use it more. So everything I made was pretty little, but yeah.
No, but that's awesome. It looks like you quickly wrapped your head around what the machine is all about and like how to use it. And then your graphic designer skills, I think, is going to really be exciting to see how that plays out with the laser, that you've got the ability to design in that vector space really nicely for it. So that's awesome. Those were 3 really great starting projects for the laser. Oh, yeah, you're good. Ooh, yeah. Question from in the room. How many of those things did you like draw yourself and then imported so that you could cut them on the laser?
I drew the cat and the keychain myself, and then the Hylian shield, I just didn't feel like tracing, so I bought an SVG off Etsy for $1 because it was like late at night and I decided I wanted to cut it, but I didn't want to draw it. So yeah, I did that. But there were like a few little finicky things that happened when I imported it to Inkscape. Like I had my settings correct in Illustrator, but then when I imported it over to Inkscape, there was like, I kept having these issues with my red line, which was my vector line that I wanted to cut, and it like wouldn't recognize it. So I kept having to change it over to like a green line or a blue line for some reason. I don't know why. But once I did that, and then also made sure that I did object to path, it fixed it. So yeah, that was a little hiccup that I had, but yeah, everything like printed fine after that.
Cool. Yeah. The laser and like its relationship with Inkscape is definitely bizarro sometimes. Like you've got to figure out what weird thing it wants you to do and then just do that until it's happy. So it sounds like you found a good workaround for the hiccups. So that's great. Cool. Norm, you're also in the virtual room. If you're around, would you care to share what you've been up to this week?
Yeah, I should share my screen, I think. Can you see it?
Yep, we can see it.
So I showed some of this last week. I kind of like landscape things, and that's photograph of an island. Did the the Inkscape version of it, and then cut it, and it looked nice. This is off mission, but I decided to do a stained glass version of it, which came out kind of nicely. And then I found a couple other landscape things. Many of these areas were too light to really come out properly, so I had to modify the file before it could be cut and shown up. A lot of this dark stuff is actually dark stuff masked in a little dam here in another version of it. So I was a landscape recorder this time.
That's really cool. I love how you're able to take that photo of a scenic vista and sort of simplify it down into a nice monochromatic look. That you're able to really capture sort of the coastline without having any detail other than just like effectively white and black. It's really
Yeah,
nice.
you can't really see it too well, but this tree here I didn't want, so I had to copy the water and paste it over. So here it looks more like just water. And I filled in where the shoreline should have been in here, because it does have to be a high contrast sort of print.
Yeah, it looks like that worked like a charm. You're definitely getting good at landscapes onto wood pieces. I like can't wait to see that zoomed out onto a nice big piece of wood where it's engraved really beautifully. I'm like waiting with bated breath for the big version.
Yeah, these are pretty small. Well, this one is 6x3.
Oh, that's pretty big.
Yeah.
And then the stained glass, did you do that on the water jet?
No, maybe it could be done in a water jet. I did it in a stained glass studio. A lot of this you can cut with a glass cutter. Most of it you can. This
Ah.
stuff here is kind of like a water jet, sort of, except it's by hand. And I can't really zoom in on that, but it's a tree line, so it's up and down. It could just as easily have really have been a more simplified outline. This isn't really necessary. I could have cut all the trees off.
Huh. Yeah, that's really cool. I mean, I love your exploration of these coastal things. I'm imagining they'd all be on one big wall in your house.
Yeah,
Yep. Oh, that's fun.
I don't know how
Cool.
to shut off screen sharing.
Oh, I think I can probably figure out how to do that. Great.
we go.
Okay. I got it. All right. So now we're gonna do sharing in the room, and it's a little wonky, but Ashley was pretty clear that the sound is best if we just get up and everybody sits here. It's the best way for it to come across, and so I want to try and make sure that the sound is not terrible. And Vincent, if you want to try and work out the sound for you first or last, what do you think we should do? Maybe you go last. We'll do all the in the room people, and then you're like kind of both at the same time. Are you good with that?
Bring my laptop over there and.
Just lean in front of the mic. Yeah, we can totally. Let's wait until the end, and then we'll try and finagle that in with everybody. So, is anybody like ready to pop up and share right now? Got things ready to go? You're pulling things out. Yeah, let's. So, let me see. Just come on over, and you can have a seat, and we'll do this. I'll hold the things for if you want.
Okay. So that's unassembled and that's assembled.
Cool.
I decided I wanted to try a box, but I also wanted to, see what it's like to come up with an image and get that cut into it, as well as some lettering. So I did two. I figured, well, I did one, let's try the second one and learn something from it. So we just decided to take 3 passes at cutting this, not 1, not 2, but 3.
Cool.
But we didn't know, did we really need 3? So on the second one, I tried 2, and guess what? We needed 3.
Yeah.
So I took a knife and I cut through where it wouldn't go. Anyway, so it makes it nice and flexible, but there's another thing I learned is that I was able to bend it around and hold it and get the bottom to pop in. But I kept thinking my preconceived notion of this was it would be a box that would open and close and open and close, but it doesn't. It's a fixed box if you do it right. So once this would snap into place and go there, you wouldn't want to open it again because that's what gives it its rigidity.
Oh yeah.
But I wanted to open and close, so I glued a piece inside
That's a good solution. Yeah.
to hold it so it doesn't need the top. Then I drilled 2 holes, and I've got 2 holes here, and I'm just gonna actually use some bookbinding thread, and so at least it'll open and close and I can put stuff in it.
Cool. A nice homemade hinge.
Yeah, and so the lettering I did in Illustrator and converted to outline. It became a path. And this I did in from a photograph of mine. I pulled it into Photoshop, made it high contrast, and pulled it into Illustrator, made a vector, and then brought it in, and all the files worked fine.
Cool.
So,
That's great. That's like the secret sauce when you get all the files to transfer.
yeah,
For sure.
yeah. So it was a lot of fun.
Awesome. Very nice. Thank you. All right. Next up, I guess we're just going around the room. Basically.
So I made a number of boxes. This one I made out of some cut plywood. I also made a kind of Christmas ornament thing for a friend of mine that was an image etched and then also vector cut. And I also vector cut a bunch of cardboard and made boxes. And the cardboard worked. I was talking to Corey about it. It worked like fantastic. It's totally cool. My experience with vector cutting the plywood was that I had to go 3 passes at the power setting that was recommended.
Right.
Did you design that in boxes.py or in MakerCase?
Not boxes.py, because for some reason, every time I typed it in, it wouldn't open, it wouldn't go there.
Okay.
Yeah.
I don't know why.
It's bizarre, but boxes.py, if you type it in, the browser's trying to open the file boxes.py and not go to the, it's bizarre. They needed better branding for their website.
Yeah.
But I'll send it directly.
So
Check it out too.
I messed around with boxes.py and MakerCase, and I found that the boxes.py files gave me like a really tight fit, and the MakerCase did not. This wouldn't even come close to staying together. So I just was like messing around with and used wood glue, and it worked pretty okay. But there's like wood glue schmoo in there. So like maybe like CA glue or something like that would be better. I have no idea.
Pay them.
Yeah, right. This was just like a piece of scrap that I had, so I just made a box real quick with it.
Is that boxes.py or MakerCase?
This was from MakerCase. Yeah.
Yes, I think was also.
Okay.
Yeah, so it doesn't fit for.
Yeah.
Yeah. Boxes.py has some boxes with flexible hinges that will open and close
Right.
on the
Yeah.
flexible hinge. And those are really nice.
That's,
Yeah. But I had a lot of fun with the laser cutter, and I think it's like totally cool. And like I already in my head am kind of like thinking about 3D things that fit together that are a little bit more complicated than this, like sliding tops, that kind of thing. It's pretty cool.
That
Yeah.
is exactly a good way to start exploring those shapes.
Yeah.
Boxes.py has an area where it gets into alternate hinging and
Yeah.
integrated stuff. And
Yeah.
took that link Slack last week.
Yeah. But yeah, that was it. And I don't have my ornaments that I made for my friend because I gave them to him. So
There you go.
But I did.
Got some cool stuff that we've been up to.
Say, I want to make one like the thing.
yeah, but this, I don't know, it's a great design.
I just laser cut my like logo into my cutting board that we started off with. It got some burnt around the edges 'cause I didn't tape it. So I'm gonna sand it down, and I had a little, for some reason, my file, the inside of the letters wouldn't come through, so this was all filled in. It's just an outline, but it's okay. So I did that. Then I showed y'all the acrylic from last week. I just was like, I'm not gonna finish that sign because I don't need it. I don't even want it. So I was just like, we'll come back to it maybe some other day. I'll keep all the pizzas and maybe one day. But I think like after one of the things I want to make this week also is my nephew. I told him I was gonna make him like a tooth fairy nightlight. I was gonna do it with vinyl on acrylic, but I think I'm gonna do it like sketch the acrylic and put his name on it for Christmas. Because I'm getting him this little like astronaut that projects the like galaxies on the ceiling. So I was like, oh, that might be cute together. And I don't know, he thinks he's supposed to get a lot of money from the tooth fairy. So all his teeth are falling out. So I was like, give him a little light. So yeah, I just did it on the bottom of both of these things. This is just a piece of wood that I just literally just glued together stuff together at home. But I just wanted to try out my logo on this as I started making like other little stuff. But yeah, this is like a stand. It had glasses on it.
That's really cool. I love that piece. Like as a whole, it's really
Mhm.
neat. And I love the idea that you're just like flip the thing over and put my brand on it.
Yeah.
It's super practical and like very, very like a great use of the laser.
Yeah, definitely. Yeah, I found some really beautiful, like little vintage glasses. So I was just like, been just playing around with different things to put them on top of. Yeah, because they're really pretty. They need a little stand. Thank you.
Cool, really cool. All right, we're gonna loop back around to you, Vincent. So Alina, you wanna pop over and have a seat in front of the camera?
So I am working, so if you recall, back whenever we did LEDs, I had a long-term goal to make a little desk doodad for my dad, who used to fly C-130s in the Air Force. And so I found an SVG file that was a diagram of different images of the planes that he used to fly. So my idea is to carve those into acrylic. And I did battle with that SVG file to get it like positioned exactly where I wanted it. And then Gigi helped me a lot today on the actual laser cutter. So I don't know if you, I can't even.
I'm sure pretty well.
And so, well, I can do it on my shirt. I don't know where the best way to do this is. So this was our first attempt with the first settings that we did. And it just kind of like melted. The lines aren't as crisp. So did the next set of settings. And this one is a lot more crisp, but it's still just rastered on the surface. And if there were actual LEDs illuminating it, we want it to be deeper cut into the acrylic. So Corey has some suggestions that I'm gonna try right after class to actually cut into the acrylic some more. So that's the idea. And this is my scrap piece. Once we have it figured out and the depth the right way, then I'll go get my actual sheet and then get to work on the stand.
Oh, and you have some crazy wood that you're working with.
Yeah, I took a trip to Norwalk to the Woodcraft fair and spent way too much money on wood for Black Friday. But they have really cool wood there. It's very small, it's like little tiny sheets, and they've got a lot of wood for the lathe, like for turning. But if you want to look at my cool wood, take a peek. Woodcraft, it's like a chain. They have them all over the place, but Woodcraft, one word in Norwalk.
It's hard for me to oversell how cool this wood is. It's like one of them feels like a piece of metal. Others are just like all over the place for like they're all sorts of colors, all sorts of materials. Right. Some purple. I'm gonna hold the purple heart. Purple heart. Purple heart is like wood that is legitimately purple. If you've never seen it, it's a really wild material. And it's like brilliantly purple in color. This is the natural color of the wood. So it's really cool. Yeah.
Can you mention how much you? So these, it's like a set of 4 that were about this long and probably this width. And they were on sale for Black Friday, and I think I got those for like $40, but they look half off. So
Yeah.
I would I probably will not spend that much again unless I make this very special. I'd rather just like go online and find it somewhere.
I've been having a hard time finding words or like people who are open during,
Reasonable hours. Yeah. Yeah. It's that part is definitely tricky. But there's a few options, so we'll see. And then Annie is with us. Do you want to show? We made some stickers today. You're all right. Annie's been traveling, and we're happy that she's back. And you can.
The cute robot. It also did this one, make this one because it's very effective, like the Christmas
Cool.
spirit. So yeah, and I'm planning to to work on this project this week. And it looks very exciting. I'm looking forward to it.
Yeah. Well, it's you hopped right back in, going right after it. So great work. All right. And then Vincent, I'm gonna change some settings so that my screen doesn't make any noise. Or how do you think this should work best? You present and then come over here and talk to my microphone.
Would it sound better if I did that?
Cool. Yeah, let's do that. Great. So it should let you present, and then you can just pop over here and talk to this microphone. If you haven't ever 3D printed a fidget spinner, they're lots of fun and very, very easy to do. So you can download all sorts of crazy things, and this is a fun one. Bearings like this, I just bought 100 pack for $25. So like they're a quarter a piece. All right.
Oh, cool. Where's the mic? Is it over here?
It's the red thing.
The red one. All right. Just excuse me, I'm committing crimes against my battery. So I printed Gigi from Kiki's delivery service, which you can see here.
Really cute.
I found an SVG that online and just modified it so I'd be able to have it laser cut. I also ended up using Inkscape to design a logo, which is just text in like a circle pattern. I don't have a picture of it here, but I plan on also cutting that out. On the side, I also learned a little bit about casting, making a mold, stuff like that. So that way I'd be able to make a mold of the snail here. So that way if I mess up the paint job again, then I'll be able to churn out copies real quick. Make them in different colors, try things like pigment powders, stuff like that. This is how the first one turned out. And the second one is going to be of the fish that's supposed to go along with the snail. This one was done differently. Instead of having like a cube where I pour everything in, I'd have to use clay and fill in one half, pour on half of it, take the clay off, and then pour the other half of it. This is still a work in progress. This is the first mold. Yeah, it looked pretty weird when I took it out today. Yeah, so I've got a little more cleaning to do, but this is what it looks like now. I'm too afraid to like cut out too much because I'm not sure what I'm supposed to keep. And there's a decent amount of math that's involved, but they have calculators that you can use to find out all the stuff you need to plug in. So that way, you know, the right like mixture. Like to make the mold, you have to do like part A and part B and stuff like that. Mix it up for a long time.
I really like your 2 + 2 = fish, so that's good.
Thanks. And yeah, that's about it so far.
Cool. Yeah. Thanks for sharing. Awesome. So it sounds like we've done a lot of really cool stuff over the week, and the laser cutter is a great way to make stuff. 3D design is just going to get us better at making things for the 3D printer in the long run. That's essentially what we're going to look at next week. But this week, it's good to just like open some 3D design software, play around in it if you've never done that before, and then go for it. I really think of it as like a video game. And so when I think about it that way, it just clicks right in my brain and I want to do it more. If it was my job, I don't know if I'd feel the same way about it, but you know, that's how it goes. But it's good to open those up, play around, and do some 3D printing. And even if you're not 3D printing a thing that you've designed, there's some like really exhilarating feature of that where I designed this, now I'm printing it, and it comes into reality. But it's also really fun to download a really cool octopus and then just print that, and then you have a cool thing that you've made. So there's also, because just the stack of like, how do you go from file to print to thing, and then get it off the bed and make all that work. There's some details in there where you definitely owe it to yourself to just have at least one easy print in your life of some weird knickknack or a fidget spinner or something. So definitely go for that this week. And then next week will be more 3D design, more 3D prints, and then maybe even how do you export a 3D design to the laser cutter. So some of those things we'll be taking a look at next week to expand this idea further. And then we'll have a wildcard week to follow up, where if you still need more time figuring out how 3D design works, we can absolutely do it. This week, I'll be around on Thursday and Sunday, as always. And then tomorrow I'll be in. I'm going to be working with Ashley on some stuff, some logistics at about 5:30. I think she's going to run some stuff on the laser too, want some backup. But then tomorrow I'll be around for a little while, and then Thursday and Sunday as well. So that is it. Stephen, anything to add? Anything that I missed?
No, I mean, Tinkercad, it's great. It feeling intimidated by the whole notion of 3D because they have very manageable tutorials, you know.
That's true. Yeah.
10 minutes, you build project 1, 10 minutes, you build project 2, and then, you know, sort of builds up, and it did wonders for me trying to wrap my head around it a few years ago.
Yeah, Tinkercad is fantastic. And it's like able to do, I've seen people do really high-end stuff in Tinkercad. Like you can model the Apollo space lander, maybe not with all the parts, but like a really good detailed model of it, all the way to like kindergartners that put a few cylinders together, and it's like a, you know, a zebra enclosure or something, you know, like the way the little kids do with macaroni and glue, except now it's less sticky everywhere because it's on a Chromebook, and remote kindergarten is very weird. But Tinkercad can cover the entire range of skill sets, so you can see all sorts of different things. It's a great place to get started if Fusion 360 feels like it's not your jam right out of the gate. So with that, and without any further ado, I think we did it. And if we wanted to go downstairs and find some 3D prints and just set some things to go, we can absolutely do that. So cool. All right. That's it, everybody. For those of you who are playing along at home, have a great night, and we hope to see you this week. Bye.